perspective on blended anesthesia delivery for small animals.
Thank you, everyone, for joining us today. I think today Kent Scientific wants to bring awareness to a topic that's near and dear to what we look at in the research industry and how we try to redefine our products to make better products that then can go into the preclinical world and make research more redefined for everyone. And I think today what we're going to look at as the room air company, as we've been looking across the most recent research, we're finding that there is room for a more nuanced conversation, and that's what we're here to have. We're going to look at what has historically been done in our industries and other industries that will use inhalant anesthesia, and they're also going to look at the typical standard points of view, the 100% oxygen point of view, the 21% room air point of view that we have discussed for so long. Today we're going to be joined by Dr. René. He's going to be bringing his decades of experience in both the preclinical and the pharmaceutical world. He has many years of experience with different training techniques that use a variety of tools and protocols that are used in everyday labs. And so he's going to be bringing us the research and a more nuanced approach to the historical view and how we can all redefine and refine our anesthesia protocols moving forward.
Yeah, so we're looking at the science behind the carrier gas you're using. You have to give your anesthesia in some sort of carrier gas. So historically, 100% oxygen, that's one of those things you don't think twice about it. You hook up your vaporizer to your tank, you turn them both on, and you go.
In the past, we simply copied everything that was in the veterinary clinic. And that was a mixture of nitrous oxide and oxygen. And that was approximately 40% oxygen should be the minimum that you have in your gas. So we are getting back to that a little bit.
If you look at a lot of recent research, we're finding a lot of times that using high oxygen percentages, such as 100% oxygen, can actually produce off-target effects that you're not intending.
It's not the one or the other. It's somewhere in between, probably. In the past, we used oxygen and nitrous oxide as they did in the veterinary clinics. Nitrous oxide was not as effective in small rodents, so that was skipped. On top of that, it was teratogenic, so we were very happy that we could take that out. But when we put our animals under injectables, we must remember that the cardiac output and the respiratory rate are dropping. And that means that the SpO2 is dropping as well. And in fact, evidence is accumulating and several papers have been published about animals breathing room air or mice especially breathing room air are simply hypoxic.
I think the perspective I'm coming from today is that we're talking about changing an industry practice that has been in place for many years and is the standard across all labs that I'm aware of is to use 100% O2. It could be argued we do this because it's historically what everyone has done, but it's also eliminating a variable of what reducing oxygen supplementation would look like. So I think what I'm searching for today is the evidence to say that this industry standard needs to be looked at, needs to be reconsidered. Proof that we're not doing this out of opinion, but we're doing this out of fact that there is a better way. Because I think we're all here to search for a better way. And I'm open to a better way. I just want to see the evidence that, hey, just because we've always done this, 100% O2 is not always the answer. And maybe to the other side of the argument, we're worried about what SpO2 looks like over long periods of time when you're using room air. So I think if we can see room to grow in between those two numbers, we can find a great way forward.
A lot of times 21% oxygen or room air is sufficient and you don't see any sort of inflammation, you don't see any sort of damage to lung tissue. It winds up being better objectively for your animals. So it's really weird looking at all this recent everything that's come up and, well, what do we do now? So at Kent Scientific, we really do recommend and we do give you that option to use room air because it's quicker, it's easier for the user, and it does wind up being better for your animals a lot of the time.
So on the topic of room air, one of my main concerns and one of our concerns that we've seen in practice is that SpO2 can become a variable that we have to be concerned about. To say that at 21% oxygen over longer periods of time, we can sustain proper levels of SpO2 within the blood, we're making a claim that we don't always see in practice that can't be reproduced over and over again to the level that we're comfortable making that a standard within our practice. I'm not ready to move on because I've seen potential complications with lowering my supplemental oxygen from 100%. And that's a variable I'm not willing to move forward with unless I can see more evidence that it is safe at lower levels.
Yeah, so not all procedures are created equal. And if I'm doing a intrathecal injection, which it should take all of 5 minutes from induction to taking my animal off, then if my carrier gas isn't really going to make that much of a difference and there's not a lot of time for my animal to become hypoxic in that 5 minutes, then I'm at the point where is giving them that oxygen really the better thing? Is it worth introducing that variable and possibly like downstream affecting my studies, even if all my animals are getting exposed to that same agent, that same anesthesia, that same oxygen? Well, how is it really going to affect my study? And looking at research translatability to humans, humans don't usually get 100% oxygen. Yet, I think medical grade gas is usually 21, but it can go up to 30. So if I'm getting there, I'm getting procedure. I'm not going to be getting the same oxygen percentage my animals are. And how does that wind up affecting how my study translates to humans?
Yeah. Okay. Thanks for sharing your opinion. I think it's not so easy. It's not either room air or 100% of oxygen. There's a lot of room in between. Evidence is accumulating that 100% of oxygen is detrimental for the brain, for example. It's connected to Alzheimer's disease, for example. So we should be very careful. Synaptic transmission can be influenced. There can be all kinds of deviations in your animal model when you have 100% of oxygen. So we should think of something else, and not of the 100% and not of the room air, and go somewhere in between. And I think 30 to 50% of oxygen in the mixture could be a good way forward. Yeah, I think the transition between room air and oxygen is in fact based on papers of James Marks and others, where they really showed that these mice under injectables are simply hypoxic. And a lot of animals are still under injectables and not only inhalation anesthesia. So the people at Kent had a wake-up call when they saw that animals breathing room air under injectables are hypoxic.
If I'm crashing on the operating table and I am hypoxic on the operating table, I hope my anesthesiologist is going to give me an extra kick. So maybe, again, that's something we should be translating into our animal work.
Exactly. Because people are dying on operating tables with 100% of oxygen.
Exactly, yeah.
On the other side of the spectrum is we give 95% from an oxygen concentrator, or we give 100% oxygen from a cylinder, and then we will be fine. Now, that is not true. At those high concentrations, the damage is done by these ROSs. So we should be very careful. And the truth, as often, is in the middle. So we should look there for concentrations of oxygen that we can use safely, and do a bit more research using those concentrations and looking at all kinds of parameters that we know are deviating using 100% of oxygen. So evidence is accumulating that 100% of oxygen produces a lot of reactive oxygen species, and they are on one side protecting the body, but on the other side they are toxic. And we should be very careful with these high concentrations and this toxicity, especially in the brain, in the lungs. And therefore, it could be a good idea not to use the 100%, but go a little bit lower. If you are doing lung research, you should never use high concentrations of oxygen. And then those people say it's better to use the room air. So that's another side of the spectrum. Yeah, this is another one. Benefits of 21% oxygen compared with 100% oxygen for delivery of isoflurane to mice. Yeah, acute respiratory acidosis, elevated arterial pressures. Those are things you see with the 100% of oxygen when you give it. There's more to know. This is an interesting paper of Singer. It's dangers of hyperoxia. Yeah, explains a lot what is going to happen at high PaO2 levels above 300 millimeters of mercury. So yeah, they call it the Janus-headed thing here. You go from left to right because you need ROSs as they are vital, and you don't want them because they are toxic. Another paper, and that's an interesting one. Found it today. It's Clutton, and it's in fact the basis of what O-Care is about. They say you should not give this 100% of oxygen, but you should dilute it, and they show you ways of doing that with some mathematics on the other side. Then there is this paper on oxidative stress that affects synaptic plasticity. That's especially interesting for me because I did a lot of work on presynaptically located adrenoceptors, and yeah, this is alarming. These ROS overproduction is doing a lot of damage to the brain, and it's also linked to Alzheimer's disease at the moment, for example. So I think we should be very careful with 100% of oxygen. I think the message should in fact be very careful with high oxygen levels, be careful with low oxygen levels, giving your animal only room air.
We've seen when you use 21% oxygen that SpO2 levels can fall. And we know that that is going to affect homeostasis, and we're going to see complications with the animal because of that. With 100% O2, there is no clear evidence as far as what I've seen or in practice. As long as we have them with enough oxygen and everything's getting oxidated, and everything is getting sufficient oxygen supply, we're decreasing the risk that they're going to have complications with homeostasis and that oxygen levels are going to stay where we need them to be.
Yeah, that could be true. But on the other hand, these ROSs are doing a lot of damage in the body at high oxygen concentrations, and you should take that into account as well.
Yes. So, at the end of the day, you can give your animals room air and minimize your physiological variables. You can give animals 100% O2 and, mitigate whatever variables do your cost-benefit analysis. But at the end of the day, it doesn't matter what carrier gas you used if your animal winds up dying on the operating table for whatever reason. So when we introduce O2 care, when we introduce supplemental oxygen, you just get that extra option where if you're noticing your animal's SpO2 is decreased, you turn on supplemental oxygen. It doesn't have to be all the way up to 100%. It can only be in that 50% range. So you wind up just at the end of the day, doing what's best for your animals, and that winds up doing the best thing for your research.
Exactly. So in laboratory animal science, we work with the 3 R's. So it's a form of refinement, and that will ultimately lead to a reduction in animal numbers, and you will have better data and more reliable data. And that's what it's all about. In the book of Paul Flagnell about laboratory animal anesthesia, he mentioned that percentages between 40 and 50% are probably the best choice. This is also confirmed by some publications. So it would be great if we had a machine that could give us variable concentrations of oxygen. And this machine has now been introduced. It's the O2 Care.
So I think what Dr. Remie has helped us see by comparing these 2 points, finding the more nuanced research that's in the middle, is that there is room for all of us to further refine our anesthesia protocols, looking at what's best for the animal. And from the conversations we've had today, it's clear that what's best for the animal is an approach that allows us to blend our oxygen into more middle ranges between room air and between 100% O2. And that's the conversation we've been listening to, and we've been hearing it. And at Kent Scientific, we've not only heard it, but acted on it. And now we're introducing our SomnoFlow O2 Care. The product is designed to meet that demand for a more specific approach to our anesthesia protocols. And we're going to give you the option to not just have to choose between room air or 100% O2, and we can all go on this journey together of actually using what's best.